Greetings to all learner. Welcome to this bridge course session on physics. My name is Suraj Mashilka, working as an assistant professor at All India Sri Shivaji Memorial Society's College of Hotel Management and Catering Technology, Pune. We will be moving to the next chapter of physics, which is properties of matter. The topic that we'll be discussing in this chapter today is the thermal properties of matter. Before we begin with the session, let's have a look at the objectives. The first objective in this session is to explain the definition of temperature and heat, to understand the various properties of matters and states of matter, to identify various changes in the states of matter, to identify the thermal properties of matter. These are the four basic objectives of this session. So, welcome to the exploration of thermal properties of matter, a fundamental topic in the field of physics and material science. Understanding these properties is crucial because they influence how substances respond to changes in the temperature and how they transfer heat, which are essential for a wide range of practical applications and natural phenomena. At the core of this topic are two primary concepts, that is, temperature and heat. While these terms are often used interchangeably in everyday language, they have distinct meaning in scientific context. Temperature is a measure of the average kinetic energy of the particles in a substance, indicating how hot or cold the substance is. On the other hand, heat refers to the transfer of thermal energy between systems or objects due to a temperature difference. These thermal properties are not just theoretical constructs, they have practical implications in everyday life and numerous industries. From the design of thermal insulations in buildings to the operations of refrigeration systems and the study of climate dynamics, understanding how matter interacts with heat is vital. Throughout this session, we will see the combination of theoretical discussion and a basic practical examples to ensure you grasp the fundamental concepts and know how to apply it in the real world scenarios. So, let us take some time and understand some interesting concepts of thermal properties of matter and also check the thermal behaviors of materials in the environment. So, to understand the thermal properties of matter, let us first define temperature and heat. Temperature is a relative measure or indication of hotness or coldness. A hot utensil is said to be high in temperature, and an ice is to be said with a low temperature. An object that has a higher temperature than other object is said to be hotter. Note that the hot and cold are relative terms, just like tall and short. We can perceive temperature by touching. However, this temperature sense is somewhat unreliable and its range is too limited to be useful for scientific purpose. We know from experience that a glass of ice cold water left on a table on a hot summer day eventually warms up, where a cup of a hot tea on the same table cools down. It means that when the temperature of a body, ice cold water or hot tea in this case, and its surrounding mediums are different, heat transfers takes place between the system and the surrounding mediums until the body and the surrounding medium are at the same temperature. We also know that in the case of a glass tumblers of ice cold water, heat flows from the environment to the glass tumbler, whereas in case of hot tea, it flows from the cup to the environment. So we can say that Heat is the form of energy that is transferred between two systems or system and its surrounding by virtue of temperature difference. The SI units of the heat energy transferred is expressed in joules with a capital letter J, while SI unit of temperature is kelvins with a capital letter K, and degree Celsius is commonly used unit of temperature. When an object is heated, many changes may take place. Its temperature may rise, it may expand or change state. In short, temperature is a measure of the average kinetic energy of these particles in the substance. It quantifies the degree of hotness and coldness of an object or environment and is a fundamental physical property in thermodynamics. Temperature determines the directions of heat transfer between objects. That is, heat flows from an object with a higher temperature to one with a lower temperature. And heat is a form of energy that is transferred between systems or objects with different temperature. It flows spontaneously from a hotter object to a cooler ones. And this transfer of energy is continuous until thermal equilibrium is reached, meaning both the object attain the same temperature. Now let us move to the next part, the states of matter and their properties. So, what do you think is a matter? Matter is anything that has mass and occupies space. It is composed of particles such as atoms and molecules, which are the basic building blocks of all the substance. The matter is very important. Matter makes up everything, including living things like plants and animals and human beings, whereas non-living things such as tables and chairs. Matter exists in various forms or states. Matter comes in three different states, that is solid, liquids and gas. That means that everything is either a solid or a liquid or a gas. The first one, that is solid. In this state, matter has a definite shape and volume. The particles are closely packed together in a fixed arrangement and only vibrate in place. Example includes ice, wood and iron. The next one, that is liquids. In this state, matters have a definite volume but take the space or the shape of a container. The particles are closely packed but can move past each other, allowing liquid to be viscous or flowy. Example is water, oil and alcohol. Then we have is the gas, that is gaseous matter has neither a definite shape nor a definite volume. The particles are far apart from each other and move freely, filling any available space. Example includes oxygen, nitrogens and carbon dioxide gases. Each state has their own properties. Now, what are the properties of matter? A property that describes how an object looks, feels or acts. So, that means that the liquid looks, acts or feels different than the solids or the gases. So, the first properties of solids. Solids do not change shape. Let's take an example of a paper. You crumble the paper. Paper may be crumbly, but it won't change the shape of the paper. In solids, the particles are compact and close to each other. Hence, they do not have space to move around. These particles on the solids are in a aligned array. Properties of liquid. Liquid takes shape of their containers in which they are poured. Liquid have a surface tension where they move closely to each other. The particles inside are far but go hand in hand together. The next property is the properties of gases. Gas is invisible. So why do you think it's invisible? As the particles in the gas are far away from each other and has a property to move freely. So these were the basic properties of matter. Let's take a simple example of properties. Now think about a can of a soda. What do you think? All three states of matters are present in the can of a soda. What part is a solid matter? Is the can that is made up of a metal. What part is the liquid matter? The liquid, that is the soda which is there in it. What is the gas matter in that? There's a CO2 which is present in that soda. Hence, making all three parts visible and available in a can of a soda. Similarly, a human body has all three states of matter. That is, the solids are the bones, the muscles that are in your body. Whereas liquid is anything but the water that is present in you and the blood. Whereas the gas are simply those that we inhale and exhale, which is inhaling of oxygen and exhaling of the carbon dioxide. Now, changes in states of matter. As you know, these matters have a capability or possibilities that they changes their state from one state to the other, which is also known as the phase transition, which occurs when a substance changes from one state to another, which may happen due to addition or removal of certain energy. Typically, it's a form of a heat. Now you can see a small chart in front of you. This chart shows how a state of matter changes, where solids change to liquid when a heat or a temperature rise happens. This process is called as melting, whereas liquids changes their state from liquid to gases if there is a lot of heat applied, which is called as vaporization. Now these changes may also happen in a reverse way. That is, gases gets converted to liquids with the help of removal of the heat energy, which is called as condensation. Whereas sometimes liquids get converted into solids, which is called as a freezing stage. Now this is how the states of matter changes. In some cases, solids directly get converted into gases without even moving into the liquid state. That process of transition is called as sublimation. Whereas when the gases directly gets converted into solids is called as the reverse sublimation. Now these are the form of state changes. These changes of states are physical changes, meaning the chemical identity of the substance remain the same, but its physical form changes due to the energy exchange involved. Heat and temperature have some other significant effects on matters other than the physical change, like influencing its volume, the speed of its molecular movement, etc. Which are, first one is the thermal expansion. What happens in thermal expansion? Solids mostly expand when heat due to increased atomic vibration. Example, metal rods lengthen when heated. Liquids also expand with heat. Water, however, has a unique property of expanding upon freezing. Gases. Gases expand significantly when heat, as the kinetic energy of the molecule increases, causing them to move apart. Next change is the change in the volume. Solids and liquids both expand when an increase in temperature, though liquids expand more than the solids for the same temperature change. What happens in the gases? Gases exhibit a more pronounced change in volume with temperature changes due to their low density and high mobility of their molecules. Third is molecular moment and kinetic energy. What happens in this is the increased molecular motion because of the high temperature mean higher average kinetic energy of molecules, leading to more vigorous movements. Also, there is certain pressure changes. For gases is in a confined space, an increase in temperature results in increased pressure. Fourth change is the thermal conductivity. When heat transfer, heat always flows from a region of higher temperature to one of the lower temperature, which can change the state and temperature of the matter in contact. Conductors versus insulators. Materials vary in how they conduct heat. Metals, for example, are good conductors, while wood and plastic are the insulators. There is certain chemical changes and reactions also. Reaction rates. Increasing the temperature generally increase the rate of chemical reaction due to higher kinetic energy, leading to more frequent forceful molecular collisions. Phase-dependent reactions. Some reactions only occur in certain phases, that is, solids, liquids and gases, and temperature changes can facilitate their phase change, thereby enabling or inhibiting reactions. Thermodynamic properties. Entropy. As temperature increases, the entropy disorder of a system generally increases, whereas the next is enthalpy. The heat content of a system can change with temperature, affecting phase transitions and reaction, which is enthalpies. Understanding the effects of heat and temperature on the matter is a fundamental in physics, chemistry, and engineering, also in various applied sciences. These principles govern a wide range of natural phenomena and technological process. Now, let's move to the last part of this session, which is thermal properties of matter. The thermal properties of matter describes how substances respond to the change in the temperature and how they transfer heat. These properties are crucial in understanding and designing materials for various applications, from everyday objects to complex industrial process. Key thermal properties of matter include specific heat capacity, that is, the amount of heat required to raise the temperature of a unit mass of a substance by 1 degree or 1 Kelvin. Next is the thermal conductivity, the ability of a material to conduct heat. High thermal conductivity indicates that the material can transfer heat quickly. Example, metal, while low thermal conductivity indicates the material is a good insulator. Example, woods and plastics. Thermal expansion is the next, that is, the tendency of a material to change its dimension, that is, expand or contract in response to the change in temperature. Linear thermal expansion measures the change in length, while volumetric thermal expansion measures the change in the volume. Next is the heat capacity, the total amount of the heat required to raise the temperature of an entire object by 1 degree or 1 Kelvin is heat capacity. Unlike specific heat capacity, where is per unit mass, heat capacity depends on the total mass and composition of the object. Next is the latent heat, the heat required to change the phase of a substance, that is, from solids to liquids or from liquids to gases, without changing its temperature, is the latent heat. The types include latent heat of fusion, which is solids to liquids, and latent heat of vaporization, which is liquids to gases. All these thermal properties of matter, we will be understanding and discussing them in depth in the next few sessions. With this, we come to an end of our session. Before we conclude, let us have a small recap. In this session, we have started with a new chapter, that is properties of matter. Under the same, we have seen what is the definition of temperature and heat. We have also seen the various states of matter. Those are solids, liquids and gases, and how these states of matter undergo changes when some energy, specifically heat energy, is applied. And lastly, what we have also done is we have enlisted the thermal properties of matter. Thank you so much.